Okay. Working out the stationary points. Okay, we'll be given y equal to, and then we get dy dx is equal to, and then we solve dy dx equal to 0. Right? And when we solve dy dx equal to 0, then we will get our stationary points. So let's say we get a stationary point at x equal to 2 and x equal to 5. Then we must determine the nature of those points. So the nature of the points, what can they be? Well, it could be a maximum turning point. A maximum turning point will look like so. And that is the stationary point. If that is the case, what about the slope on the left of that point? Will be positive. And what will the slope be on the other side of that point? Negative. So it will go from a positive slope to a negative slope, and that will tell me that it's a maximum turning point. So in that case, dy dx will turn out to be positive. On the other side, dy dx will turn out to be negative. Or I could work out d2y dx squared. Now, I wouldn't always use d2y dx squared because sometimes it can be difficult to calculate it. Yes? But if it is easy to find d2y dx squared, it will turn out to be less than 0. Either of them will tell me it's a maximum turning point. It could be a minimum turning point. If it's a minimum turning point, it will look like so. That being your turning point. On the left, what will the slope be? Will be negative. And on the right, dy dx, the slope of the tangent of the curve will be positive. Now, so I'll check on a value less than 5 and a grand, so that's 5 something from my calculations of the numbers I took there. So less than 5, I'll check at 4 and I check at 6. And that will tell me the slope on either side. Or I can work out d2y dx squared. If it's easier, and it'll turn out to be positive. If d2y dx squared turns out to be positive, that means it's a minimum turning point. Or 3, it could be known as a saddle increasing. But these are the points I didn't do with you yesterday. In other words, the curve bin may be rising, level off, and rise again. And that will be the stationary point I would end up with. What's the slope on the left of it? Positive. And what's the slope on the right of it? Positive. So if you get the slope on the left of the point to be positive and the slope on the right to be positive, it is a saddle increasing. And d2y dx squared does not work for a saddle point. Therefore, you just can't know the d2y dx squared root. d2y dx squared here turns out to be equal to 0. So it's inconclusive. Here it's negative and here it's positive. And your fourth point is the saddle decreasing. And that point looks like so. It decreases, it levels off, and it decreases again. What will the slope be on the left of it? Negative slope. And on the right of it? A negative slope. And what about d2y dx squared? It's equal to 0. It's inconclusive. So the 2y, the x squared here won't work. So the only way you can tell saddle points is by checking the slope on either side. So that's why we wouldn't be that much interested in the 2y dx squared y, but it doesn't work for our saddle point. At this stationary point, what's dy dx? It's 0 again. And at that stationary point, dy dx is, now this isn't a great graph. The red should have been a bit more horizontal, yeah? Do you understand that? So first of all, can you find the stationary points? You can. You work out dy dx, you solve dy dx equal to 0, and that gives you the stationary point. Now once you have found the stationary points, then you must tell me what they are. So they're either maximum or minimum turning points, or saddles increasing or decreasing. 4 point type that you have to be able to distinguish. They will all work by getting the slope on either side. Yes? And the maximum minimum one only works by what? Getting the 2yd x squared. I forget what I was saying. But anyhow, the 2yd x squared only works for these ones. When would you use this one? Well, if it was an x cube going to a quadratic going to x, that's an easy one to get. Have you any questions? Do you understand that? All right, so then the only thing you have to be able to do is know how to